Okay, so we're ready to start with our visualization studio. So we have Corey Nathy, who's one of our LabKey developers, and Catherine Richards, who's a staff scientist at the Fred Hutch, and Catherine's been working with us on the HiCore IQ project. And they will be talking about data visualization, scientific principles, design choices, and implementation in LabKey.
All right, thank you, Avital. So we're going to talk today kind of in three sections, and this is a working session, so we're going to try and take questions in between each of these three sections a little bit and then save kind of the longer session questions at the end. But at first, Catherine's going to start by talking about just kind of data visualization in general, scientific principles and design choices that make you think about what visualization you might present for the data you have. I'm going to come back in after that and do more of a demo of some of the built-in visualizations within the LabKey server itself, so just using some built-in tools and focus more on the JavaScript client-side visualizations. And then we're going to talk about the HiCore IQ project. So there was a talk yesterday by Karma about the HiCore IQ, but we're going to show a little bit more of a demo of the plots themselves and talk about the implementation for that case study itself. So I'll pass things over to Catherine.
Thank you. You can all probably hear me anyway because it's such a small room. So what I'm going to talk about for this first part, and really our kind of going back and forth is really reflective of how Corey and I have kind of really worked on developing all of the visualizations for HiCore IQ, is the first part is really just, talking about, why you use data visualizations, choosing the best chart type and visual attributes, and incorporating design best practices. And even before that, three things that kind of came to mind when Dave was giving his talk earlier on, I think, the data space visualizations, is unfortunately, so he had a really cool, scatter plot with brushing effects and all that kind of stuff, which is probably what everyone wants me to talk about. We're not going to talk about really cool, fancy, cutting-edge visualizations. What we're really going to talk about is the principles. And one is because before you even start to do really kind of fancy visualizations, it's really important to know the basics. So what was inherent in Dave's scatter plot is all the basics were there in terms of, really good design choices. Obviously, he's a designer, but especially in thinking about, there was some thought process that went into a scatter plot and why should we have a scatter plot, and maybe why a scatter plot alone isn't enough, maybe why we need these other kind of scatter plots on the sides to show the data that isn't typically there when you do a scatter plot, and those are the things. So those are the kinds of things I'm going to be focusing on at the beginning. So you already know that kind of stuff. You can just, maybe ignore me for the first part, and then you can talk about more how you implement these things in LabKey, but that's what I am going to focus on. And also, that it's really important to know your audience. So depending on, so for example, the scatter plot also that Dave showed was very interactive, and it's kind of much more of maybe a data viz for exploration. Sometimes you may want to do a data viz for explanation, which is you already know the story, you already know the ins and outs, the reliability of the data, those kinds of things, and you really need to tell a story. And so in particular, HiCore IQ is much more of a reporting tool meant to communicate with hospital administrators, heads of insurance companies. We already, to some extent, while it is a little bit of an exploration and letting people look at things, it has to be much more high level. We can't get into the weeds of data quality, have it be too much of exploration, because again, we have to know our audience and making sure that we're really conveying things in the way that they want to know it. So it's going to be high level type data. So going on kind of like why use visualization. And again, this is, going over the basics, but the really great thing about visualization is that it, leverages your visual system to absorb large amounts of information very quickly. It can inspire new questions. It can help identify problems. But it's also, you use data visualizations for a purpose. You don't just kind of use them because maybe you've had too many words on your slide, now you want to show a picture. I mean, there should always be a purpose as to why you're creating a visualization and you're showing it. And so kind of a good example of why you use data visualizations is because they can show patterns tables do not. So if you, had just looking at these four kind of data sets, and you were maybe to want to try to summarize this quickly, you would maybe look at, for example, the means, the average of all four data sets of the x's is 9, the average of all the y's, 7.5, same linear model, same R squared. You will look at these and you could say, well, they're generally, in terms of looking at the summary statistics, they seem the same. But when you go to plot them, it tells you something very different, right? Visually plotting them allows you to take away something from the data that you couldn't get from the kind of simple table alone. And so this is one really great way is why to use data visualizations is because they can help you understand new things about the data, identify new patterns, identify outliers, et cetera. All of you play in data, so this really may not be something too new to you, but really with all that, how do you get into now, choosing the best chart type and thinking about visual attributes? So, there's no correct way to necessarily pick a chart type, but there's a lot of tools that you can use to help you figure out what chart types to use. And then there's also understanding more about the visual attributes and how those, play out with different chart types. And so I'm going to talk about a little tool that I like to use for selecting chart types. And then also, but with that is this idea of visual attributes. So when you're creating a data visualization, one of the first things you have to think about is you have to map your data dimensions to certain types of visual attributes. And so, there's various visual attributes going from position and placement, text labels, length, size, area, color, all of these things. And so when you're making a data visualization, there's a science behind using each one of these, and some are actually better than others, and so that's the kind of stuff that I'm going to talk about. And so, again, I kind of mentioned this, but part of making a data visualization is going through this data encoding process, right? Where you're going to map data to visual attributes, and so the process is choosing your data dimensions to graph. You classify data types and then determine which visual attributes represent data types most effectively. So while here's a list of various visual attributes, there are some that are better to use than others, and I'll kind of explain why. And so if I talk about, again, just to make sure we're all on the same page when I'm talking about data dimensions, right, I'm talking about unique information. So for example, with this graph, you have two side-by-side line charts next to each other, and you have 4 dimensions of data. So you've got sex represented here in men and women. I've got smoking prevalence, which is on my y-axis. That's another data dimension. You've got cohort, year of cohort. So this is smoking prevalence over time and how it's changed, right? The cohort is the 3rd dimension, and then age, just general age, smoking 0 to 4. That's the 4th dimension. So understanding your dimensions of data is one of the first things. And in general, it's most common to have visualizations with 3 or 4 data dimensions. It's very rare to have 6, 7, or more. And because the more dimensions of data that you have represented, the more visual attributes you need. And the harder it can be then for people to take things away from your visualization if you have more attributes. So it's part of the trade-off of making them. But again, this is all kind of simple, but I want to make sure that we're all on the same page when I talk about this, is that whenever you're making a data visualization, there really is a science to it and a thought process that should go behind it, and that you have, the first thing you have to do is understand not just how many data dimensions you have, but the data types that you have. And so, depending on, your field, you may refer to these things a little differently, so I'm making sure to represent my source here. In Stevens, back in the 40s, when he talked about kind of 4 types of data, is you have nominal, ordinal, quantitative, both interval and ratio. And when I talk about those is, because nominal, sometimes people refer to these as labels, something as that have no inherent order. So whether you're talking about apples, oranges, pears, something like ordinal, which could be restaurant inspection grades. I was in New York City for 10 years, where we were very aware of all the restaurants we were going into had an A, B, or C grade. There is an inherent order to those. And then you've got quantitative variables. One being referred to as interval, where your location of 0 is somewhat arbitrary, whether that could be, for example, a date or a location. And then you've got this other type that's called a ratio, where the 0 is fixed. So this is going to be something like a physical measurement, weight, or height. And if you ever have trouble thinking about, what type of data do I have, because sometimes it can be a little unclear, you can think about, which is a really great way to identify that, is to think about the operations that are permitted with the data type. So, for example, nominal variables or labels, right? All you can do is say this is equal to that. So apple is equal to apple, but apple isn't equal to orange. But you can't subtract an apple from orange and those kinds of things. So this is really just meant to be a reference if you're ever confused about what type of data do I have, to think about the operations that you can do with that variable. And why does all of this matter? Because the type of data that you have reflects the type of visual attributes you should be using to represent that data. So if I talk about, I've already mentioned these, where you've got position, placement, you've got text labels, length, size, area. What this table shows, and it's adapted from Designing Data Visualizations by Alinsky and Steele, is that it shows you ordered is just whether or not there's any kind of inherent order to that visual attribute. So for position placement, yes. For text labels, it can be, depending on how you basically order them in your graph. Length does. An important thing is color does not. So different hues do not have any kind of inherent order to them. It's important to know. Yet where saturation does, which means when you think about that, so an ordinal variable, right, has an inherent order to it. Saturation can be used for that. However, there is not inherent order to color, so therefore you wouldn't want to apply different hues of color to an ordinal variable or to a quantitative variable, because they're not They don't map to each other. And so, I'm saying this, but you could say, well, where does all this come from? Well, whether or not certain visual attributes are good for certain types of variables comes from really what I call the science of data viz. It comes from a field called psychophysics, right, which is just a branch of psychology that deals with the relationship between physical stimuli and sensory response, or human graphical perception. And so basically, when you're thinking about a data viz or trying to infer information from a data visualization, you have to go through a series of elementary perceptual tasks. You either are going to compare the position of two dots on a common scale, you're going to compare the position of things on a non-aligned scale, you're going to compare lengths, you're going to compare all these things. And so when you're doing this, there's actually, whether or not when I talked about, position, is order, doesn't have order, and when I've talked about choosing chart types, is that there's been randomized experiments comparing various chart types. So we can rank kind of visual attributes in terms of whether you should use position versus color to represent, as a visual attribute for your data visualization. That comes from experiments. So, for example, if I were to take these 5 different chart types, so this here is just a regular common bar chart, this is a stack bar chart. What you would do is you would take, they would randomize, 500 people, and some would get this chart and some would get that chart. And they would ask people, what is the exact value of, the bar with this dot and the bar with that dot? Or they would say, what is the relative value of this amount versus this amount? So they would, randomize this to the people as a scientific experiment to assess whether or not people were accurately taking away the information that they wanted to from the graph. Were people able to accurately say that this bar, had a value of about 15, and which chart type was the data inferred more accurately from? And so through a number of experiments that have been done on various different chart types, people could then go through and rank various chart types to say, if you want people to take away the exact value of a bar chart right here using, a commonly positioned axis, this chart type here is the most accurate versus, a chart type where there may be a little more distance or bar charts on top of each other, etc. So all of this kind of stuff has gone through where people have done experiments to be able to say one chart should be used over the other. And so, again, when we go back to this kind of general, 10 different visual attributes in terms of ranking, this is the type of perceptual task that leads to the most accurate takeaway of information, and color saturation is actually the lowest. So when you think about it, you have the possibilities to map a certain type of data to color, or you can use a scatter plot and map it based on a position. You should pick the chart type. If you're really concerned about accurate takeaway of information, use something that's going to allow you to have comparing on a common scale versus mapping something based on differences in color. And so with that, so what you can do with this is you can kind of take away general, and again, I'm kind of quickly buzzing through this stuff, which I'm not expecting to teach all of the science of data viz right here. I just kind of want to talk about little pieces, so if you want to know more about this, you can kind of learn on your own and explore. But when you think about these different attributes and then, picking charts, you can't always, like, for example, common scale could be a bar chart or a scatter plot. You may not be able to actually use those chart types for the data that you have, but you can use it to help inform the types of, charts that you're making, and maybe the ones that are available for the data that you have. Which of these can I use? That's going to be the best. Like, if I'm choosing between area and angle, maybe I want to go for an angle. For example, it's always commonly told the pie chart is the chart that some people just absolutely hate. And some say you should never use it, and there's all kinds of, you can go for hours about that. But if you were to use the general principles here of the ranking of perceptual tasks, one would always pick like a bar chart over an area, because people can better assess and take away information correctly from comparing two lengths of two bars next to each other, or comparing something against a common axis versus area. So that alone can help to guide you to maybe choose a bar chart over a pie chart. But in general, as I said, so you can use those things to kind of help make decisions about what charts you could use, but then it also becomes a daunting task to sometimes figure out, what charts can I use? And so, you can be using something like Tableau now, which helps if you have certain data types picked. It'll kind of help guide you as to these are the chart types that work with it. But sometimes if you're using, R or Excel or SAS or other things like that, and even, using the data viz tools within LabKey, you may not have those kind of things readily available. And so there's a lot of other tools out there. One that I like here is Data Viz Catalog. So what this online site is it allows you to kind of log in and look around and say, I actually want to pick a chart type based on function or by list. And so I really like the function ability, where you can go in here and it asks you, what do you want to show? Are you trying to compare two objects? Do you want to compare proportions? You're comparing location, relationships, etc. And you can kind of start to look through different chart types that would be really good to show what you want to show. Again, taking the framework of, I have something I want to tell, or maybe I have something that I want to allow people to explore. And so with that in mind, you can kind of use this tool to help guide you. What are the different chart types that maybe I should be using to visualize the data that I have? And again, if you pick any of the example charts, for example, the bar chart, what's really cool about the site is, it gives you some of the basic anatomy. And so for a bar chart, you probably don't need that because you all know what that is. But for some of the more complicated things, maybe like a population pyramid, etc., the anatomy is a really helpful kind of tool of what is this really used for. And then it also gives you a whole array of tools to generate the visualization. So, it has things, of course, like Excel, D3, Data Hero, Data Wrapper, and all kinds of other things, that you can use that are really good at that. So some unique chart types that you may have to use very specific software for that. If you want to talk about nodes in a network or things like that, there may be very specific tools for that chart that you can use. Then it also gives you variations. So if you're someone who's producing a lot of data visualizations and you don't always want to just have a bar chart for something simple, you can maybe think of other variations that you may be able to do and show, as opposed to that simple bar chart. And so then finally, there's this general kind of science of data visualization, I like to say, where you may think about, okay, the best chart type to use is, a scatter plot over something else. But then there's also the kind of, art to data viz, which, is, again, a whole area that I won't, get into, but I'll just touch on some of the basics, which is really to incorporate what I call design best practices, which is, if you're really getting into this and you're doing it, of course there's, people that are really graphic designers like Dave that probably specialize this and know this stuff way more than I do, but as someone who is trained as an epidemiologist in public health, there's the kind of general things that I try to keep in mind and pay attention to, which is, any graphic designer is going to have a heck of a lot of experience on color theory and typography, which are important things that you're going to go into when you're designing these things, such as don't just use color willy-nilly or don't just use the default colors of any of your packages. There really is a science to picking out what are the types of colors that I should be using that go together, that should be using to represent whether it's an ordinal variable or a label. These are kind of areas of, like, I'm not going to spend time on, but to think about and know about and look to. There's all kinds of tools that you can use if you want to be picking different color palettes and things like that. And then what I'm just going to talk about here is these kind of general, like, what else, Tufte's rules. So Edward Tufte is someone who's kind of was maybe, early on one of the people who generally was proposing a lot of things about, kind of simple tools that anyone can use to kind of help your data viz. And while he's been saying the same things for like 30 years, even today, still people are they're still really apply. So he's kind of these general 7 rules, which is, and I'll kind of give examples of each of these. So the first one is kind of reduce chart junk and increase your data to ink ratio, which is to say that, default, you may get a lot of extra stuff on your graph, whether you've got, grid lines and you've got your title and you've got your labels and you've got all this kind of extra stuff, which is to say wherever you can get rid of that stuff, get rid of it. Only use titles that you need to. You don't necessarily have to have both. Get rid of colors in the background, get rid of lines, that kind of stuff. When you can get rid of extra ink, basically, whenever you can, you want to eliminate it. You want to maximize contrast. So, for example, instead of having a light gray background here, you could have something like a white in the background. So it allows for the contrast to be better. And granted, these are, I'm sure we could have hours discussions on various little design details, but these are kind of general takeaways, if nothing more, if you were to take this. At least these are better to follow than ignore. Use readable labels. So, for example, it's much easier for a person to read a label horizontally than vertically. And then, he says don't repeat yourself, repetition is bad. I think some ways I agree with this, in some ways I don't. The part that I say repetition is bad is that people sometimes will use grid lines and data labels. The point of a grid line is to allow people to visually map the point to the y-axis. So if you give people a grid line, they don't need the data point because they can do that. Or if you give them the value of that dot, they don't need the grid line because you already told them it's 2. Why do they need the grid line to map it to 2, right? So don't ever use, my general rule is don't ever use grid lines and the data points at the same time because it's basically a repetition that's unnecessary. And unnecessary in terms of labels. If, the month is people generally know that's a month. You don't actually have to tell them it's the month. So some people will say 1950 and they say year. It's redundant. I mean, sometimes you can take away things like that. You don't always have to have an axis label and the value. So again, take away things where you don't necessarily seem to need them. And here's just a simple one. So instead of legends, label the data series directly. So again, this is easier said than done, especially when you're, using something like D3. It can be much harder to, take a label over here and put it next to the line than just have it in a legend. But, when you can, it's easier. And the reason why this is better is because it reduces the time it takes someone to infer information from the graph. When the label's down here, you have to go high, color pink, and then go up here. You're reducing that time where it's literally right there. And so that's why these kind of recommendations are made, is because it increases the efficiency in which people are taking away information from your graphs. And then finally, this is kind of like the simple thing, is avoid smoothing in 3D, which is unless you have 3 dimensions of data, don't use anything that's 3-dimensional. So I know a lot of people very early on like to use 3-dimensional because it's just like makes it pop and it makes it seem better. But there's, especially here, there's only 2 dimensions of data, and that I have high, medium, low, and year. There's nothing here, and that's why I kind of left it that way, because I don't have 3 dimensions of data to actually show. There's nothing inferred by this depth, so I shouldn't be using it. So in general, don't use 3D just to use it, unless you're this kind of depth would also be conveying something. It shouldn't be used. And the general idea against smoothing is that unless you have a specific reason of why you're smoothing a line, like you're doing some kind of statistical spline or something like that, you don't want to take away the kind of variation that exists in the data. Let it show, unless you really are purposely smoothing it for some kind of statistical reason. I would say you generally kind of avoid it. But and then again, sort for comprehension, which is also kind of should be pretty intuitive. But in general, especially with color, and if you have like an ordinal variable mapped to color, make sure that they're sorted for comprehension and they're not just on there. Again, color should be sorted appropriately as well as the labels. Kind of just simple tips, but it's amazing how often these, like even 7 rules, are not kind of universally applied across all things. And so those are the kinds of general, I guess, the first part of the kind of scientific principles and design choices. I don't know if anyone has like a question or two or a comment or anything before we kind of go on to now thinking about these general things, how we go ahead implementing them in LabKey. All right.
All right, thank you. So I'm going to spend most of my time kind of going through and doing a demonstration, a live demonstration, using the demo study from labkey.org. I have it on my local machine here. And we can count how many of these tough rules I broke from the examples I'm going to show. But I did want to just have a couple slides just to list out the information for reference. The built-in tools in LabKey, and I'm going to focus mostly on the top ones in my demo. But the box plot, scatter plot, time chart are things that when you walk up to a LabKey data region, you can often create box plots and scatter plots just with a few clicks and play around with them that way. But there's also additional things you can do as a developer to extend those, to use the Java visualization APIs to build your own custom reports, or like Leo showed this morning with some of the R reporting stuff that you can do with RServe and Knitter and other packages. And also mentioned this morning was some of the additional things you might want to do with visualization outside of LabKey. So if you really want to have your own tools, you have processes set up that you just need to pull the data out, there's the client APIs that Louis talked about, some of these for pulling the data out. And the one thing I wanted to mention is you don't kind of have to start from scratch with all of those. If you're looking at a grid of data and you say, this is the data I want to see outside of LabKey or I want to programmatically access, from the export menu on a lot of the grids, you can get a quick script that is kind of a template or a starting point for writing that code. And those API calls all go through the secure, auditable, programmatic data access that a user would get if they're on the site, accessing the data that way. So the tools I'm going to show, the visualizations are all built on the LabKey visualization API. I just wanted to list them out here. This isn't an exhaustive list, but just some of the different shapes and geomes that you can use from the visualization API and the interactions you can use. The presentation that Dave did this morning for the data space stuff uses a lot of the visualization APIs to actually build the chart itself, and the ones I'm going to show will do that as well. Okay, so here's the part we can start counting my mistakes. So I just have, like I said, on my local server here, the labkey.org example study. So this is generated test data for resembling an HIV disease progression study. So similar to some of the studies on other Atlas servers that were talked about yesterday. But I'm going to start by just jumping to the data views web part. This is just a listing, in this case, of all the study data sets that I have in my study alongside any queries or reports I might have generated, and just an easy way to kind of categorize them. You can control as an administrator which ones are public, which ones are private. You can give them different thumbnails or different hover icons. So there's a lot of customization you can do with this web part. So I clicked on the lab results data set just to look at one example and to show you one place you can, there's a few different places you can start when creating a visualization in the LabKey product. But probably one of the most intuitive is when you're looking at a grid of data and you found the data you want to plot, and you want to make a decision on whether you want a box plot, scatter plot, time chart. You can do those different activities from the menus here, from the charts menu is some of those built-in tools, but also from the views create menus, some of the more developer-oriented R reports and JavaScript views. But also just looking at individual columns, if I click on one of the columns here, viral load in this case, it's a numeric variable in my data set. It's marked as a measure, a plottable measure. So I get this quick chart option at the bottom. So if I go ahead and click on that, I now am dropped into, by default, just a box plot. And it's not a very, it has to make some decisions on default selection. So in this case, I have cohorts defined in my, 2 cohorts defined in this study. So it puts that on the x-axis just as a default. But then it's pretty quick to make customizations just by, for example, clicking on the axis labels themselves. So viral load, let's say I want to plot on a log scale instead of a linear scale. I can do that. I can change the x-axis variable. I know in this particular study I have another demographic variable called treatment group that I've pulled into this lab results data set, and I want to put that on the x-axis. So I can quickly make those changes without leaving the page or having to make those choices before coming to the plot report page itself. I can also change some visual aspects like what Catherine was talking about with color or size, and this is where I'm probably going to make the wrong choices based on the rules, but I'm going to show in this particular case just some of the options for a box plot. I can show all data points rather than just the outliers. I can jitter them, change opacity, size, color. The options are there for a lot of these different customizations, and quickly to update that. And then from here I could save away that report, and it would save all this configuration details, and I could then share that report with users or put it on different pages or build it up into a different web part. And also I can switch to a scatter plot without having to leave the tool. So the x-axis kind of acts based on the type of variable selected. So treatment group and cohort were categorical variables, so I got a box plot by default. If I switch to something like CD4 on the x-axis, the plot will switch to a scatter plot. So this is, again, without leaving and having to make that decision before I got here. I can kind of play around with the data and see those changes quickly. I can also add color to a scatter plot using another variable. So if I had another demographic variable, in this case I'm just going to pick country of origin for the color of my data points. I can kind of, it's a little hard to see on the screen, but see the differences based on those color selections for the variable. I did want to quickly just show a time chart. I wasn't going to kind of build one the same way I did there from scratch, but I'm trying to jump to what a saved one would be and then play around with some of the options there. So if I have again, using the lab results data set, I have a time chart here of CD4 values. Here it's just showing 6 participants in my study over time. In this case, the x-axis is a calculated variable of number of weeks since, in this case, start date. But I could pick a different demographic date if it was date of first vaccination or something else that was in my demographic data set. I can use that to kind of calculate the days or weeks or months on my x-axis. If I switch to edit mode, I can kind of show just one quick customization of a time chart. Let's say instead of just looking at 6 participants, I wanted to again look at those treatment groups. I wanted to look at the average CD4 value for the treatment groups over time. I can use the grouping menu to kind of make that change pretty quickly by changing the participant selection mode to participant groups and showing the mean value. I can also add standard deviation error bars if I wanted to, but I'm just going to stick with the mean value. And on the right-hand side, the menu changes from participants to cohorts and groups. I'm going to switch it to select all of the treatment groups. Let the plot refresh. And now we have one plot per treatment group. It's pretty jagged in this case because it's plotting weeks since start time. So maybe I want to switch that to something, to a bigger interval. So I'll switch that to months. Just to get an idea of a quick way to compare these different treatment groups. So these are HIV positive and negative treatment groups, some with treatment, some natural controllers and things like that. So I can quickly see over time what those different treatment groups are behaving as far as CD4 values. And again, I can save this report with all these customizations and share it and view it on other web parts within the study module here.
Can I make one comment about it?
Yep.
Just looking at it too, when I talk about, like, let's say chart junk, or you could even say redundancy, is here you have both, the 4 different categories are both, they're using color and shape. And so, you know, you may think about, for me, if I look at this, unless you are concerned about maybe the colors don't work for some people because they're colorblind, and so they also need the shape. But here you don't, why, you know, have it at least be a conscious decision that you're choosing to use 2 attributes for the same thing. Because right now, basically, shape and color are redundant. They're both conveying the exact same thing. So for me, I would take out the shape and just have color in the sense because it's just like extra, to me, junk on there that I don't want to look at. But, you know, at least these are the kinds of things to think about is, you know, even though it's a default R graph, doesn't necessarily mean that it's great, right? Everyone kind of always seems like, oh, well, R is great for, you know, how they look and I don't need to change anything. Is to say that, you know, sometimes there may even still be things that you want to change from the default settings here, so.
Perfect,
The
thank you.
shape is fine, redundant, I agree with you, but having those dots in the position kind of give you information, the interval kind of things, right? Instead of smooth line.
True.
It's a trend, but
So
those
if,
number
but
dots-
then if anything, then if you, then make
Or
them all,
same
then
shape
make them
kind
all
of
the same
thing.
shape, yeah, so it
that's
reduces the difference between, yeah. So I would say if you want a shape so people get the exact dot, yeah, just have it be a small circle.
Exactly.
As opposed to different shapes, because that's just adding more complexity that doesn't need to be there, that's already conveyed by color.
And I would like to say that was intentional that I left it that way, but I could have showed this plot. So anyway, the last thing I wanted to show just from this demo was a visualization I created just for this demo using the JavaScript visualization APIs as more of a dashboard. So just to show some additional chart types on the page, I took, for example, an administrator who wanted to see if the data being loaded into their studies was correct or missing. So I wrote a little dashboard visualization tool and I applied it to several different data sets. In this case, demographics, a physical exam, a couple different data sets. And in the LabKey data set, you can define columns as dimensions or measures. And it helps with some of the plotting tools to make decisions about what types of default selections we're going to make. In this case, I chose that all of the ones that are marked as dimensions, I'm going to plot using pie charts and bar charts. So to Catherine's point earlier, I'm glad I didn't just use pie charts, because bar charts might be more easy to compare, but I added both here, so that's good. But also, so I just scroll through and we can see a couple of the variables. So each column in the data set is its own kind of row here. And for example, the primary language, you can see that 83% of the rows in that data set are null. So maybe it's a quick way for an administrator to say, oh, there's something wrong with my data feed that I might want to look into that. And I can quickly scroll through here and just look at the distribution of these variables. And then when I get to the bottom, one of these variables happened to be a measure. So the demographic data set had a height variable. So I'm just displaying it as a box plot here, just to show how they can all be displayed together. All this is using the LabKey visualization APIs. And again, the same code is applied to multiple data sets. So if I scroll down here, I've added them using the reports web part to this particular tab in my study. And I can kind of just scroll through them and see the distributions for the different variables. I did want to just point out a couple other examples of interesting visualizations and kind of choices that have been made and visualizations have been done over the last year for different groups. So the panorama group was presented on this morning. It didn't talk specifically about the visualization, but this is one thing they're doing to track quality control. So they're using Levy-Jennings reports and Pareto plots to do quality control, but this particular plot uses kind of this blue region you see as a way for the user to interact with the plot and actually click and brush within the plot to select data points that will then create a guide set. So all those data points in the selection are then used to take the mean and standard deviation and be compared against future data uploaded into this particular folder to get comparison of quality over time. My next example was from the data space project, and this is along the same lines as what Dave showed this morning. And he talked about this gutter plot, or this, the additional, not only the scatter plot in the middle showing the data points that are in intersection between the two assays being plotted here, but also not throwing out the data that might just come from one data set or the other that might be valuable information. So laying them out in a certain way might be able to convey that information using the individual axes or just additional plots laid next to each other. And the third example I just wanted to show was Argos. So this was a talk yesterday at the end of the day. And they have several different visualizations, again, all built, in this case, these 4 examples, all done using D3 to render the plots on the client side itself. The first 3, the pie chart, this survival curve, and the bar plot are all using the LabQ visualization APIs. But the 4th one on the right is interesting in that it was actually a tool that was developed by another group at the Fred Hutch, the STTR group, called Oncoscape. And it's again a JavaScript D3 rendered plot, and they were able to build that tool and integrate it into the Argos product and use the data feed from Argos to plot, in this case, a timeline of patient event data for the population that's selected. So in Argos, you can filter down your population pretty easily by making different choices, and the plot will update to show the patient events over time for that population. So that's the kind of second part of a talk. Any questions on that before we jump into kind of more detail about the high core IQ section? And again, there should be time at the end for some further questions if needed, but the high core IQ project, I'm going to turn back over to Catherine to kind of give an overview of it, and then I'm going to come back in and do a live demo on that as well.
And just 2 things I wanted to mention that came to mind when Corey was talking was when I felt like I was like the parent scolding him for like bad choices, but like with the pie chart, really the reason it's important to just even know that there is such a thing as like kind of the science of different chart types is that with a pie chart, when people usually are critical of it, it's because when you think about the ranking of perceptual tasks, for the ability for people to understand area or arc length, is not they're not great at it. Which is why generally, if you have 5 different pie slices, this could be almost impossible for people to really take away which one is the larger or smaller one. But if you understand that that's the reason why pie charts aren't good, then if you actually put the label of the pie value there, then you're taking away any need for people to assess, arc length or pie, width and stuff like that. So if you are going to use a pie chart, so I'm of the, thought that you can use, pie charts can be used as long as you're giving people the value of that pie slice, and then also not to use a pie chart if you have too many slices, because then it gets cluttered with ink because you're actually putting the value on it. So that was one thing, and the other thing too is that you can have a lot of data viz isn't art, and so you could have extra lines or even those shapes with the color if you want, but in general it's these general things that you should maybe do and try to do most of them. You don't have to do all of them, but do most of them. It's going to make your chart look better. And also that Stephanie Evergreen is someone who is a really great kind of I don't know what you would call her, but data visualization designer. And if you go to her website, she has an excellent checklist of about, I don't know, a couple pages long of things that if you actually kind of can go through and rank your data visualization that you make. And like she likes to say, like if you get like 80 or 90, in general, it's good. But so the idea is that there's a checklist of things that you should generally follow. And if you can do most of them, it'll probably be good. But if you get a really low score kind of on our checklist, you may want to rethink that I've kind of violated, 10 things. This really may not be a good thing. So That's it. And so then just, again, so in general, Karma Kreisenbeck from my group came yesterday and talked about HiCore IQ. So I'm just going to, only briefly introduce it, which is that it's meant to be a regional oncology informatics platform that really, it's a reporting tool is mostly what it is. And so we are trying to report information to payers and providers about how they're doing or how clinics or physicians are doing in regards to adherence to metrics. And again, the metrics that they're following, we use Choosing Wisely recommendations, which are just our recommendations based on the American Society of Clinical Oncology best practices. And our goal with HiCore IQ is really to be allow users to select the metrics they want and different configurations to see how either their clinic is doing, the regions are doing in regards to these various metrics. And so really with this, we didn't get any fancier than bar plots or line plots, so there's nothing, it's pretty simple, but in the same time, keeping in mind kind of, the things that I talked about at the beginning, I was really not just looking for any tool, so I don't just use D3. I try to find, the best ways to kind of apply what I wanted to be able to do. And for any of you, those, D3, it's way harder, especially me not being that skilled in JavaScript, can be way harder to remove a line or put a line somewhere or add labels directly to the line than you want. And so sometimes it's about looking around. So what Corey's going to talk about with the example plots is I actually use a library called Dimple, which allows you to write and make modifications to the graphs in a much easier way than the kind of long length of writing it all in D3. So now he's going to kind of talk about that.
Great. So again, this is another demo run from my local machine. This is all test data, but it's the same tool that's used on the HiCore IQ site. So it's just modified data. So I'm going to start by just clicking on one of these links that jumps us right into the tool itself. So with this tool, there's different metrics of data that can be loaded into the system. In this case, we're looking at the use of chemotherapy and radiation therapy at the end of life. So one particular metric, but the same plotting tools and charts would apply to the different metrics that are loaded into the tool itself. And in this case, the link is directly to a line plot. But you could start out by saying, I want to look at this metric and go to the customized report page, like I'm going to do in a second, and make decisions about what you want to see and let that drive what chart type you're going to end up with. So in this case, the line plot is showing the utilization percentage over time, with the time being days prior to death. And on the right-hand side, it gives an idea of the population size, so the total number of participants that are being aggregated are shown in this plot. And we're going to add some filters in a little bit to show it would also list the population filters that I've applied. But another interesting part, and I think Carmen mentioned this yesterday, is that this is sensitive data, so there's population size restrictions. So once you've filtered the data down, you might end up in a case where a given category is lower than that population size restriction. So in this case, the server doesn't return information about that. It kind of cuts it off at that level and says we're just going to exclude that from the plot itself, rather than and show something that might be identifiable. So if I go to the customized report page, these are the different options that are built in right now to switch between plotting types. But again, it's more about picking what you want to see. So in this case, I was plotting the data broken down by race. I'm going to switch it to stage, for example. Let's say we really just wanted to look at one time point. So I'm going to pick 90 days prior to death as my time point, and add a couple filters. So each of these checkbox columns in this case are the dimensions of data that are kind of filterable. So there's an XML definition applied to the data summary table itself that kind of define which columns are dimensions and which are plottable measures, again, and the ones marked as dimensions kind of show up here in checkboxes that you can add or remove different categories. So if I hit update here, we've now switched to a bar plot showing that particular time point for, in this case, the stage breakdown, since I switched that. And on the right-hand side, you can see the population filters that I selected. And again, another population group is restricted because of that size restriction. From here, the user can download the graph, which includes not only the SVG image itself of the plot, but the right-hand side information, as that gives it a valuable context when you come back to that exported PDF later. Just to show one more quick example, if I go back to Customize Report and switch the view from viewing by region to viewing by clinic, and I'll remove some of my filters here. I update the plot again, and now we switch to a scatter plot. So now we're looking at the utilization percentage for each clinic, with the x-axis being sorted by rank, so that we have the higher utilization percentage on the left going down on the right. And the plot also gives information about the regional average for your selected filtered population, and those all update as you kind of go back and forth between the customized report page and this plot itself. So just to talk briefly about the implementation of this, again, like Catherine mentioned, it was definitely a high level of collaboration between HiCore and LabKey, not only for the layout and design of the user interface itself, but for the code. So I think the original version of the plotting code that was written by Catherine in D3 and sent over, and we at LabKey integrated it with kind of the data pipeline, so that the data coming in and added the filtering capabilities of the customized report. But then we also went through another iteration of the D3 code, switching to that Dimple library to kind of simplify the code itself and make it easier to change things. And I'll show a quick code example in a second. This is all built into a custom Java module. It has its own database schema that's created from the module using SQL upgrade scripts. It uses an OLAP cube for accessing the measures and dimensions of the data. And again, the data security part. So the data is not directly viewable by the user, so only the administrator that uploaded the data could go to outside of the plotting tool and actually see the data in a grid. And again, that's aggregated data that's loaded into the grid, but the users themselves, if they went to that same grid, they wouldn't see any of the records. The only way they can access the data is through these API calls that are made by the plot itself. So, and again, that's a second level of aggregation that's happening based on your breakdown selections and filters that you've made. So there's additional levels of aggregation that make that obscure as well. So this is the quick code example, and I'm just going to switch to the second slide here. So this is for the bar plot, and this is just one example of picking the right tool. If you can look out there, there's a lot of different tools out there, even just for D3 rendering of plots. In this case, the Dimple code on the right-hand side was where we started for, this is just rendering the y-axis, some different parts of it, so generating it, setting the ranges and domain for that y-axis. And on the left-hand side is what it ended up with when we switched to the Dimple JavaScript library. So it's more about just setting the configurations and letting the tool itself, the library, handle a lot of the display. So there's some future directions that the HiCore IQ is working on and developing. This sprint, they're adding a more general way of defining new metrics and loading new data into the system without having to go back to the schema and do SQL upgrade scripts to do it in a more general way. We talked about splitting the module, and this is another thing related to the collaboration, where the JavaScript code for the plotting itself is where a lot of the iteration comes in. So we talked about splitting that from the server-side code, which handles the security and data loading, and making them two modules that kind of can stand alone and be iterated on separately. And then additional things like having a user log in and be able to identify which clinic or which data point they are, but not identify the other data points, so that they can compare how their clinic is doing, and including other chart types like static reports, dashboard reports, and submetrics. So I think that's all we had. We could take questions on any of those sections on HiCore IQ specifically, or the kind of design principles, or we can kind of let people talk about visualizations or go around and help you out as well.
Quick question. So it seemed like when you were doing the demo there that when you made the different choices, that you got a different kind of plot. So you've got the smarts in there to kind of, is that correct?
Mm-hmm.
That depending on what you select in terms of what filters or what kinds of things you want to show, you choose a different plot. Is that?
Yeah, that's correct. And also, which I almost was thinking about this morning, I maybe should have included, is we actually spent a lot of time at the very beginning with lots of mock-ups of the whole experience, which actually took a lot of time thinking about. If I want, having time in there, and if I want to look at something across time, I have to be able to do this, but then actually the filter for time has to happen and not allow you, like if you pick 30-day, it has to switch the chart type and then switch the things that you can kind of filter because then the grouping is different. And so there was actually a lot of thought that had to go into the ability to go back and forth like that. So yes, I mean, it is in there. So you have, and that's why even while it's relatively seems simple now that we just have line charts and bar charts and a scatter plot, there was a lot of initial work going into just the whole ability to function, switch between all of these things depending on what you were choosing.
So how generalized do you think any of that logic is? I mean, that's kind of what I struggle with looking at. Some of these great products out there, but you have your own sort of space of data that you're working in, right?
Mhm.
So how do you see any things from the logic that you put in there that wrongly applies to anybody else, or are you making a product for your set of data?
You're probably better able to speak this. I mean, I would think, I'm sure that the logic is easily applied to other groups and uses.
Yeah, but you did talk at the beginning about a lot of the decisions you're making are kind of upfront about the data you have. Like, you don't want to just show a bar plot for the sake of showing a bar plot. It's the data you have that kind of drives some of that.
Right, because it makes sense for that situation of your data.
Yeah, yeah. So in this case, it was easy for us to build that logic in because we knew the shape of the data, so we can switch between the chart types based on the selections. But that might be, it's something that's tougher to generalize as you change the shape of the data or what variables you might have available.
Yeah, so some of it would need to be tweaked, but the logic would generally be there. So instead of maybe going from a bar chart to a line plot, you're going from a heat map to a this or something like that. So it could be little tweaks to it, but yes, in general, it is custom to what we were showing. But at the same time, a lot of that logic, especially with the filters and all of the ability to kind of use something very similar, I'm sure it wouldn't take that much to be able to change it.
All right, thank you. If there's any further questions, you can find us around as the day goes on. But thank you very much.